Hey there, welcome to Chapter 7, Lesson 5. Remember, Chapter 7 is all about similar figures. Similar figures have proportional sides plus our congruent angles. So we're going to talk about, in this section, we're going to talk about the parts of the triangle. So if you recall, back in chapter 5, I believe, were the parts of our triangle. So if you recall the word altitude, which is also the height. Remember, it goes from your vertex and is perpendicular to your opposite side. So we're going to talk about altitudes. We're going to talk about angle bisectors. So that means that it is a segment that cuts one angle into two congruent parts. We're also going to talk about median. So remember, a median goes from the vertex to the midpoint of that opposite side. So those are the three parts that we are going to talk about in this section. They have a major part in similar triangles. We can use some characteristics of these parts in our similar triangles to solve for missing sides, or so on and so forth. So these theorems, 7, 8, talks about our altitudes. Remember, it goes from the vertex perpendicular to the opposite side. If two triangles are similar, so we have to know they're similar. And remember, proportional sides, congruent angles. The length of the corresponding altitudes are proportional to the lengths of the corresponding sides. So knowing these two triangles are similar allows me to create proportions with our corresponding altitudes. So notice this first part of my proportion is AD, the altitude, over my altitude. Altitude over my altitude equals, and then I can use any corresponding sides. So in this case, they have used AB and FG. So a side, I'll just put a side over a side. So you can create these proportions using these parts. All right, so same thing with the angle bisector. It works the same way as the altitude. Remember, angle bisector cuts the angle into two congruent parts. So if my triangles are similar, I can set up a proportion using my angle bisector. So LP is an angle bisector over RT, which is an angle bisector, equals, setting up your proportion, you are going to do corresponding sides. So a side over a side. And just make sure that if triangle 1 is on top here, triangle 1 is also on top there. And try not to flip-flop them. And then, again, same thing that can happen with medians. Medians go from the vertex to the midpoint. See, because I know my triangles are similar, I can set up my proportion using the median. So median of triangle 1 over median of triangle 2. So they did CD over X or YZ equals the side of triangle 1 over the side of triangle 2. And remember, those have to be corresponding sides as well. All right, so let's put this into play a little bit to see how it works. So I have two triangles that are similar, which are that's great. So then we can use our proportions. And this looks like a median. Remember, medians go from the vertex to the midpoint. So because of these tick marks, I know that M is a midpoint. I know that T is a midpoint. So I can say my median, 12, over my median of the other triangle equals, and then X corresponds with 5, so I can say X over 5. You would not want to do 12 over 8 equals 5 over X, because that first triangle needs to be on top of the proportion, and the triangle 2 needs to be on the bottom of the proportion. So we're going to keep going. 8X is equal to 60. Divide by 8, so X equals 7.5. Alright, go ahead and stop this video. Check your progress real quick. Here's your answer, and notice that this is a Altitude, it goes from the vertex and is perpendicular to your opposite side. Again, same setup for your proportions can help you with that. All right, we're going to go all the way to our triangle angle bisector theorem. And notice we have one triangle here. Before we were comparing two triangles that were similar. This one is just one. So an angle bisector of a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. So notice that my angle bisector splits this side into KM and ML. So because I have JM as an angle bisector, I can say that KM over LM, the side that it cuts it, equals JK and JL. So circle over your circle equals your square over your square. I'm just using some symbols to keep it similar. That says the same thing as that if you like it that way. All right, so let's try it in a problem. I have one triangle and I have an angle bisector, which allows me to say that the side that is cut by the angle bisector, so x and 6, is proportional to 15 over 9. Just make sure that x and 15 are consistently there and that 9 and 6 are consistently on the bottom together. So cross multiplying, because that is how we solve our proportion, 9x equals 90, x equals, I don't know why I would divide by x, x equals 10. Right, and there's one more to finish out working on this triangle angle bisector theorem, if I can talk correctly. And here is your answer. So you can use proportions like we have been with the parts of our triangle talked about in the section. Thanks a lot. Have a great day.